this semester. So again, here's the link. So this is the module that I put up before last week or the week before, and this is the general YouTube playlist. So can you see this general playlist now? So let me talk to you, Brian, because you were talking a minute ago. Are you there?
Yeah, I can see
Yes,
it.
so you can see the general playlist, right?
Yeah.
And all of these things here are in the same order. I'm going to go back. So now you can see the module on Canvas, right? So that was the general playlist. Can you see it now, Brian? I just want to make sure that everything.
Yeah, you're talking about like looking at the theory of the firm videos, right? And then seeing the videos here?
Yeah. So I just clicked on this link, and this was the whole playlist on YouTube. And now it's broken up by the titles into different sections. And so hopefully you guys can see all that. You can see, can you see this, Brian, that like some of them deal with like this one, the Monopoly homework. You can see the homework on the screen there, right? So that's what I'm talking about, is that as you guys go through these things and you're going through the homework, then, you know, you can focus on the sections you want to. Like I said, it's a lot to watch, but you don't necessarily have to watch every single thing. I'm not assuming that you guys always do. But the videos that we've already covered for sure were the cost videos. And so now that you've seen these things broken up by the topics, again, they're in basically the same order that they were in the YouTube playlist. It's just broken down a little bit more. You can see that we're covering profit maximization, and we've already talked about that after we discuss costs and where costs come from. And then we have a couple of things that we want to talk about once we get past competition. Now, in, you know, large measure, we've already covered competition, because competition is what we see in the typical supply and demand diagrams that we, and the supply and demand models that we talked about at the early part of the semester. So that's why we kind of skip. You'll notice there's a homework assignment of competition, and if you try to click on it, it doesn't show you anything. And we skip straight to the Monopoly homework. And then we want to focus on Monopoly cartel, and then these things that I talked about earlier, which are the concept of the Cournot-Nash equilibrium, the Cournot duopoly model, and then we finish up with the leader follower model. And really what we want to do, and I'm going to in lecture focus on specifically those things that are most important for our last midterm. Okay, so the last exam that you're required to take if you don't want to retake any exam because you didn't do well on it, and then this will be, you know, your third midterm will be your final exam for the course, meaning final is in the last exam, right? So I'm going to focus on that. Now, if you go through these videos carefully, then you'll realize in the homework and in the videos, there's some coverage of some topics that I'm not going to emphasize in the lecture as we continue on. It doesn't mean the material is not important. It doesn't mean that the material is not on the homework, because some of it is on the homework. But what I'm going to do is focus on just the material that you'll be responsible for on the third midterm. So if you go and you study the other material that's outside of what I'm going to be talking about in our remaining lectures, that's perfectly fine. It's helpful. But if you're studying for the final, meaning our last midterm exam, and you're interested, well, okay, like which questions from Ignithium is Dr. Hunter going to choose, and how are they going to be presented? Then if you go back to the lectures that I'm recording right now, then you'll see the material presented in the way that I think is most helpful for being able to complete what's going to be expected on the third midterm. So is that clear? Do you have any questions for me about that?
Okay. So basically everything from now and forward is what's going to be on the final midterm.
Yeah, that's right. And but again, what I wanted to kind of, there's a little bit of subtlety in what I'm saying, and that is, if you look at all the videos that I've posted here in the third module, there'll be some topics, again, on the homework and in those videos that I don't think is, really focused on what I'm gonna expect you to know on the final. And it's related to, but it's not a sharp focus. So I'm gonna hear in lecture for these, next couple of weeks, I'm gonna try to just focus in on the way that the material is going to show up on your last midterm exam, so that hopefully that gives you a better chance of nailing the third midterm, instead of having to retake it. Not that you can't, but because that's eligible too. You'll see if you score less than 70% on the ignifium portion, then you can retake the third one during finals week, and that's okay too. But I'm hoping that those of you that are not needing to retake anything else can do well on the third one. So that's why I'm going to just try to focus on the way things are going to be presented, and hopefully in the most helpful way to help you all do well on the third midterm. So I'm not going to cover everything that's on all the homeworks. Okay, so that's the main part. Okay, so are there any questions about that for me? No. Okay, so that being in mind, let's talk a little bit about this material. Okay, so Brian, can you see the whiteboard now?
Oh yeah.
Okay, good. Okay, so let's midterm number 3. Okay, so we're gonna have for topics competition and monopoly, porno, and Stackelberg. And I want to also tell you that hopefully you remember at the very beginning of this course, there was this overriding topic, and you may have forgotten it now, but I'm going to bring it back. It's the first fundamental welfare theorem, right? And you may remember, or hopefully you do remember, but basically the first fundamental welfare theorem says that competitive markets are efficient. And then it tells us that there are 3 ways in which you can have a market that's otherwise competitive, right? Meaning there are lots of firms, lots of buyers, and lots of sellers, and they can interact together and they can achieve an equilibrium. But then you'll have what we call a market failure. Okay, and a market failure is when a market fails to be efficient. Okay, so I'm going to put, but we can have market failures. And you'll hear the term market failures a lot in a lot of courses that you go through, but the market failures fall into 3 categories. One of them is market power. And then you might remember the others are externalities. And I could put externalities and / public goods because they're very closely related to one another. And then the last one is asymmetric information. So for a market to be perfectly competitive, it has to have no asymmetric information problems, no externalities, and no market power for any of the participants. So this last section of the course, we want to illustrate with monopoly first, and the existence of market power and how that causes inefficiencies. So again, this is all related to supply because monopoly and oligopoly, again, these and I'll write oligopoly. That's the bigger category that includes Corno and Stackelberg. Monopoly and oligopoly both represent circumstances in which the businesses that are doing the supplying, the firms, have market power. And market power is the ability to, and I'm going to put in quotes here, manipulate market price to one's advantage. Now, basically, what does that mean? Well, so remember that competitive firms have no market power. Like that, okay. And the way we show that is we say that they are price takers. So you might have heard price taking behavior before as one of the descriptions for competition, but it just means, you know, the competitive firms, the story is they're such a small part of the overall market that if they charge a price that's at all different from the market price, that they won't be able to stay in business. So if they try to raise their price, which is what a firm would want to do, right, to bring in more revenue, to try to raise their profits. So, but firms with market powers or market power. So for example, I'll say monopoly has the ability to, and one of the things that might be helpful as a reminder is that when a competitive firm, and this is one of the things that we talked about last time, right? When a competitive firm maximizes its profits, it ends up charging a price that's equal to its marginal cost. And the monopolist has the ability to charge a price that's greater than marginal cost. Okay, so that's the condition of the monopolist's equilibrium, because the monopolist has market power, and that enables the monopolist to earn supernormal profits, and that in and of itself isn't a source directly of inefficiency. Earning profits that are greater than a competitive firm would earn. But it turns out the way that the monopolist earns those profits actually does cause inefficiency. And that's what we want to focus on. So in order to do a good job of this, the topic that we've already covered that's closely related to everything that's going to follow is joint costs. Okay. And so we begin by focusing on the joint cost, because joint costs enables us to model both competition and monopoly in a way that we can see directly how the monopolist market power ends up causing inefficiencies. Okay, so that's the first part that I want to emphasize. So in order to really understand these ideas well, you have to do something probably that you're not used to, and that is you have to begin to tell yourself a story about how an industry forms. Okay, so how does an industry form? Because what we're going to do is we're going to tell a story basically about an industry that consists of multiple firms, and under different circumstances those firms are going to behave in different ways. Sometimes they'll behave like a monopolist, and sometimes they'll behave like competitors, and sometimes they'll behave like an oligopoly. So there's a limited form of competition between them. And so we take the simplest example of an industry. So an industry is just a collection, or you could say a group of firms that are supplying the same product. And if you, I don't want to distract too much from what's going to, be the nuts and bolts, or the essence, the important part of what's going to be on the third midterm. So I'll just say this in passing. So they're supplying the same product. So you could think of, a group of farmers that all supply wheat, or a group of farmers that all supply oranges, or and sell them into the same market, and they compete for the same customers. That makes up an industry. You could pick another product like tennis shoes, or another product like coffee cups, and you can think of a bunch of different businesses that are all making coffee cups. And so they're supplying the same product, and they're competing for the same customers, or supplying those to the same group of customers. So defining the market's a little bit harder than defining the industry. And we're interested in the industry because when we draw a supply curve, that's almost always going to be an industry supply curve. So defining the industry is a little bit easier than defining the market, because the industry tells us, what are all the businesses that are supplying the good. But when we talk about the market more generally, the industry is obviously going to make up the market supply, but who the customers are that they're selling to, that gets a little bit more difficult, because it could be divided on the basis of geography, or it could be divided in some other way, maybe over time or something like that. I mean, geography, I think, is probably the most natural way, but these days, geography is less and less meaningful because customers are, potentially, global, could be the whole earth, right? So you buy something from Amazon, you buy a coffee cup from Amazon, and you don't know if it came from Taiwan or from China or from England. It could have been from anywhere. But if you think about, the market for tomatoes in the southern United States, it might be, the case that a local market there just has local customers, within, 3 or 4 states in the southern United States, Mississippi, Alabama, Louisiana, and Missouri or something. And that's your market. And you can then readily identify, who the suppliers are. But the point is, if we want to talk about an industry, the simplest industry we can talk about is, and we picked the simplest one because we want to be able to work with the mathematics in the simplest form possible. Now, everything that, I'm going to do can be extended to, multiple firms in an industry, more than just 2, but the math is just going to get messy really quickly. So we're going to do what most theorists do, which is, and this is, intermediate microeconomic theory. Most theorists will pick the simplest possible example as an illustration of what they're trying to demonstrate. So the simplest possible industry is an industry with only 2 suppliers. Okay. So again, if you've read or watched the videos on the joint cost function, then you'll realize that we can take the 2 marginal cost functions of the 2 suppliers, and we can use that to construct a joint cost curve that is basically going to represent the industry supply curve, but there's more to it than that. We're always going to be appealing to the joint marginal cost function, but we're going to be looking at the joint marginal cost function in different ways, depending upon whether these firms are behaving like they're perfectly competitive, or they're going to be behaving like a monopolist. But in order to do any of those things, we have to work with the joint marginal cost function. So joint marginal cost is how we represent the combination of the 2, and I'll put again the 2 different suppliers. Okay, so I'll say a little bit now about joint marginal cost, and so let's talk about joint marginal cost. So I'm going to go ahead and draw some marginal cost functions. And okay, let me go ahead and talk to somebody. Sophia, you here this morning?
Morning, Professor.
Hi, how are you doing? So are you following what I'm talking about so far? Is it, I'm not saying it's all perfectly clear, but you see where I'm going?
Yeah, with the industries?
Yeah.
Yes.
Okay, so the reason why I wanted to talk to somebody is I wanted a little bit of feedback. So I'm gonna draw over here on the far left-hand side, I'm gonna draw the marginal cost for one particular. Now, this is the thing that's very, very subtle, and the language can be tricky, okay? When I think about a firm, right, the idea of firm is really about ownership and control of the manufacturing capital, what we would call, the factory. Okay, who owns the factory? Well, the firm owns the factory, and the firm manages the factory. But when we think about marginal cost is really, for the most part, about how much it costs to run the factory. Do you see what I'm saying?
Yes.
There's a subtle difference there. And so I'm going to draw just as a simple, first case. So here's the output for, I'm going to call it factory one, right? And we'll measure dollars on this axis. And now I'm going to go ahead and draw a really, really simple marginal cost function. Change the color to red. And it's just a ray out of the origin. Okay. And and I'll label this as MC1. And I can even put an equation here. And this is one of the things that I wanted to show you all, is that if we look at the homework, we'll see that marginal cost is generally, we do a linear function. I'll put C1 plus D1 times Q1, okay? But do you notice anything about this very simple version, right, Sophia? So see this marginal cost function, right? It's a linear equation.
Yes.
What is different about this equation? I mean, what might trip you up about this equation and the one that's illustrated?
Is it not like the y C1's like the y-intercept and the,
yeah, and the y-intercept in this case is 0, right?
Yes.
Because it's passing through the origin. Yeah.
Yep.
And so that's the case that I want you all to think about. If you go through the homework, a lot of the examples have a C1 that, and I'll go ahead and move it, that's like this, okay, where it has a non-zero vertical intercept. But the simplest case is one with a 0 vertical intercept. And so you'll see some examples later on in the homework where you're dealing with 0 vertical intercepts. But for our last midterm, the 0 vertical intercept case, which is simpler than the non-zero vertical intercept case, is the one that we're going to be using and emphasizing for our last midterm. Okay, so this super simple case where C1 is 0 is what we want to think about. So as you go through the homework, if you get hung up on one of the problems where C1 is not 0, don't freak out, because you can go through the videos and I explain in, complete and thorough detail how to handle the cases where C1 is not 0. But for our purposes, for the third midterm, we're just going to be talking about cases where C1 is equal to 0. And that's because we have a time limit on the third midterm, and dealing with the algebra of non-zero C1 cases can be very tedious, and it can take a lot of time. So we're gonna that's on the homework, but it's not gonna be on the third midterm. Okay.
Okay.
So I wanna, and so I'll do this. Hopefully this makes sense. Okay. That's what we're going to be dealing with most of the time. Okay, you said put a little X over the C1. So we're going to ignore that case. So let's go back and think about this a little bit more. So we've got this one factory, right? And these are the costs of producing that factory. I produce a certain unit here, Sophia, and then I go up and I see what's the cost of producing that unit, and I can find it there on my marginal cost function, right?
Yes.
Makes sense. Okay. Now let's do another example, and we'll call this marginal cost at the second factory. And to emphasize the fact that it's not going to have a vertical intercept, I'm just going to simplify the equation, okay? Or its vertical intercept is going to be 0. And then I'll draw it like this, okay? So does that make sense, Sophia? Are you feeling good?
It's less steeper or more steep?
Yeah, it's flatter. And I drew them differently on purpose just because they don't have to be the same. Okay. So you can have one factory that's, you might call this the low cost factory, the meaning the one that's flatter, right? Yeah. But there's something a little bit hidden here, which will be important as you work through the problems. Normally, I don't know if you've ever thought about this or not, but if you haven't, that's okay, because that's why you're here. You're here to learn stuff. That if you have a factory that's really low cost, like factory 2, right, on the margin, does that mean it's necessarily more profitable?
No, because maybe they could be selling higher quantities.
Well, you see, now if they sell at the same price, now I'm kind of playing a little bit of a game with you, and I'm being a little bit tricky, because I'm looking for a very specific answer. But the thing is, it is true that assuming they're selling into the same market and they're receiving the same price per unit that they sell, the lower cost factory would be more profitable. I mean, it's really kind of like a no-brainer. If no matter how many units you were going to sell, but let's just say they were going to each sell 10 units, but you could say if one sells 10 and the other one sells 20, it wouldn't really matter. Would you rather have a factory that has a higher marginal cost or a lower marginal cost? And I also want to say, and I can say it more directly by saying, would you rather have a higher per unit cost or a lower per unit cost? But I want to be careful that marginal cost and per unit cost aren't exactly the same. Per unit cost is more like average cost, right? But marginal cost is the cost per unit, but like of each individual unit, not averaged against other units, right? It's the cost of producing that unit itself. So, you know, I want to be careful because again, the language is subtle. You have to really think about, okay, you know, average cost. So I'll just put ATC. Remember, that's going to be your total cost divided by Q. But marginal cost is going to be the change in total cost as you produce an additional unit. Do you see what I mean? How they're similar, but they're not exactly the same.
Okay.
They in special, there's one special case, and that is if marginal cost is constant, and it's an important special case because it comes up in a lot of problems. Okay, then MC is equal to ATC. And I should be a little bit more, you know, explicit, assuming FC is equal to 0. So there is that special case, but again, most of the time your intuition won't fail you. If somebody asked you a question like I asked you, like, yeah, if you were to produce with a factory, would you rather have a factory with a lower per unit cost or a higher per unit cost? You know, and what would you say to that?
The lower.
Yeah, obviously, right? If I can get my stuff cheaper and I can sell it for the same price, I'm going to make more money. You know, it's total common sense, right? But the thing that's really missing from this analysis, and the reason why I'm pointing it out because it shows up in some problems, is, and maybe I'll put this in pink. Okay. Don't forget the fixed cost. Okay, because when you do profit, remember that I'll go back to blue now. Profit is revenue minus total cost, right? So I can rewrite total cost as variable cost plus fixed cost. And you may remember, hopefully you do, but if you don't, I'm reminding you, that the marginal cost is related to the variable cost only. And so all you see in these two diagrams is that one factory has a lower marginal cost than the other, but you don't necessarily know why. And I'm telling you the reason. This is the typical story. So firm one has a higher marginal cost because it's an older, inefficient factory. It uses old technology that burns up a lot of energy. The typical story for this type of you know, marginal cost situation is an old coal-fired power plant. It generates electricity by burning coal and making steam, and that's very inefficient. And this new factory is super efficient. It uses some other fuel, like maybe natural gas, or I'll tell you what's a super low marginal cost, and starting to come back because people are, you know, concerned about climate change, is nuclear power. So I think it's GE. Have you heard of the Tesla Powerwall?
No, what is that?
Okay, so the Tesla Powerwall is, you know, like your cell phone battery is a lithium battery.
Yes.
Right. And, you know, like for the Tesla cars, they have like basically a big version of your cell phone battery in the car, and you charge it with electricity when you plug it in. So it's the same technology. It's a lithium battery. Does that make sense?
Okay, yeah.
Yeah. So your cell phone and your Tesla car used the same battery. It's just a bigger version of the battery in the car. But Tesla has started to produce these giant lithium batteries, like probably like the ones they use in the Tesla, but probably even bigger. I've never seen a Tesla battery out, you know, so for a Tesla car, you know, standing out. So I don't know how big they are, but they're starting to put these big lithium batteries in the walls of houses, so the houses can collect solar power electricity and charge their power wall. It's a big battery, charge their house battery during the day, and then run off of the electricity they stored in their big house battery during the night, when, you know, because obviously at nighttime there's no sun. So if you're reliant on solar power, you're stuck, right? But if you got a big battery in your house, then you can run off your battery. Well, the only reason why I bring it up is that I think it's GE has started to produce these small, and so I don't know, have you been down to South County? Does the San Onofre sound familiar to you?
No, I'm from NorCal.
Okay, well, if you take a trip down to San Diego, as you're going down the 5 freeway, you'll pass, when you get past Newport and down a little bit further, you'll notice there's these 2 huge concrete domes sitting off the coast, and it's the San Onofre nuclear power plant that's been shut down about 10 years now. But so nuclear power historically has required these huge buildings to contain the nuclear reactor that generates electricity, and so GE has started to produce small mobile nuclear reactors. I don't know if you know this or not, but the US uses nuclear powered submarines for our Navy. Have you heard that?
No, you can assume I don't know much.
Yeah, well, okay,
much.
so yeah, so well, you know, the cure for that is reading. So but yeah, so the Defense Department for a long time has used nuclear power, particularly in submarines, it's to run the submarines, and those submarines, obviously a submarine isn't the size of a giant, you know, so the San Onofre nuclear power plants, have you seen the Student Services building at Cal Poly?
Yes.
It looks like a big spaceship.
Yeah, it does.
Yeah. Like whatever, right? I don't know who designed it. But
no, it does. It looks like a spaceship.
Yeah. Well, that's about the size of a typical nuclear power plant.
Okay.
One of them. And so obviously a submarine's a lot smaller than that. And so they have to have smaller nuclear reactors. Well, GE has started to adapt the technology so that they can have these small nuclear reactors, basically, you know, to power a bunch of homes, and they're mobile. You could move them, you could build them off site at a factory, and then like a Tesla power wall, you could have your house hooked up to a small nuclear reactor. And guess what's the benefit of that? No carbon emissions, no greenhouse gases. So anyway, the only reason why I bring it up is that if you look at these 2 factories, and one of them's a high marginal cost factory and the other one's a low marginal cost factory, normally one of them's using an old technology and one of them's using a new technology. The old technology has a lower fixed cost. Do you see where I'm emphasizing the fixed cost over here with my little arrow?
Yep.
And the lower marginal cost one has a higher fixed cost. So there's a trade-off between the cost per unit and the upfront or fixed costs of building the factory. See, so you don't know which is going to be more profitable necessarily, because one can have a lower fixed cost, I mean a lower variable cost, but a higher fixed cost, and the other one can have a lower variable cost, a higher fixed cost, or the other one can have a higher variable cost and a lower fixed cost. See, so the story is not complete here. We know something about the marginal costs by looking at these diagrams, but we don't know what's going on with the fixed costs. So that's why I say don't forget about the fixed costs. Okay, so let's go back to the big picture issue. These are two factories, right? And the two factories could represent two different firms, right? Or it could be one firm owning two different factories, right? Do you see what I mean?
Okay. Yeah.
Yeah. And so the idea of the firm, normally the first simple introduction to this is, oh, you've got a factory represents a firm. This is the marginal cost for factory one, it's the marginal cost for firm one, and that's the end of the story, right? But now what we're going to do is say, well, this could represent two different factories and two different firms, or it could be two different factories owned by and run by the same business, okay? And that will affect the supply behavior, because if this is an industry that's composed of only two different production units, two different factories, if the factories are owned by different firms, then they'll compete with one another. But if it's one firm that owns both factories, then they'll act like a monopolist. Does that make sense?
Yes.
Right. And so we want to contrast, okay, what's the monopoly outcome going to look like when these two factories are owned by the same company, the same firm, with the case when the two different factories are owned by two different firms. That's really the focus of what we're doing here in the rest of the class. So I didn't get to the joint marginal cost, and I'm going to do that right now, but I got to start a new whiteboard to do it. So I'm gonna draw these again, and so I'll try to be quick about it. I'm going to leave some of the details off just because they're on the other diagram. So here are the two marginal cost functions. Again, I'll try to make them look similar to what I had before. And so, and I'll just label MC1 and MC2. Okay. And now I want to, so this is the big deal here. This is the joint MC. Okay. So what's the joint marginal cost function? Well, I don't know if you've ever heard this, but if you don't remember it, it's okay. But it's something that is in every principles of microeconomics textbook. And, you know, it's something we say in passing, but it turns out to be really important. And that is, if we have, let's assume that, are you still with me, Sophia?
Yes, I'm here.
Okay. So let's assume that these are two different factories owned by two different firms, and we're trying to get to the industry supply curve. So one of the things that you might remember, and hopefully you do, but because we talked about it already this semester, but you know, things fly by. So, and you just did an exam, so maybe your mind's someplace else. But the supply curve of the firm, so of one firm, is its marginal cost. Okay, so here, right, I could say, well, you know, this is the marginal cost for firm one, but this is also firm one supply curve. This is a marginal cost for firm two, and this is firm two supply curve. Now, the next thing that we want to do is you might remember, and this is the part that I was hoping you would remember, is the industry or market supply is the, and I'm going to draw this out so I can have a little bit more space, is the, and I'm going to abbreviate this, the horizontal sum of the individual supply curves for firms that make up the industry. Does that make sense?
I'm gonna be honest, I did forget.
Yeah, so if I've got the supply curve for firm one and I have the supply curve for firm two, you know, whenever we're drawing our basic demand and supply diagrams like we did at the very beginning of the semester, right?
Okay, yeah.
Right. I just say this is the market for something, like suppose this is the you know, market for let's pick something like tomatoes. Okay. And then I'll just, you know, casually go, okay, well, hold on, I want to do a different color. I'll just go ahead and like draw a supply curve and say, okay, there's the supply of tomatoes, right? Does it, I mean, that looks familiar, right?
Yeah.
Yeah. Well, but the question is, right? Well, I know that if this is the market for tomatoes, then, well, there's like farmer one and farmer two who each have their own supply decisions, right? How do they jointly combine their individual supplies to make up the market, right? That's the question. And the way that normally we do it is we'll say, okay, and I'm gonna draw the horizontal sum, is we'll say, okay, let's suppose there's a particular price here. I don't know, let's say the price is $1 per tomato, right? Then normally what I would do is I would say, oh, okay, at $1, right? Since these are competitive firms, they're going to choose to produce where price is equal to marginal cost. So I could go to firm one and say, okay, he'll produce, or she'll produce Q1, right? Amount of tomatoes. Maybe this is like, I'll try to be really concrete here. They'll supply 10 tomatoes, and then see what I do next here, right? So I'm gonna say, oh, okay, at the same, let's see if I can get it to, at the same price. See how I'm going along horizontally?
Yes.
Right. Firm two will produce like 20 tomatoes, right? And then at a price of $1 at the industry level, right, we'll get, and this is why we use horizontal sum, because I add up in the horizontal dimension, okay, firm one is going to supply 10 tomatoes at $1. Firm two is going to supply 20 tomatoes at $1. So at the industry level, how many tomatoes am I going to get at $1? I'll get 10 from firm one and 20 from firm two. So I'll have 30, right? And that will be 1 point on my industry supply curve, right? So I'll just pass it through there. Okay. And this is the same process for constructing the joint marginal cost curve, is that we would go up. So here's at a price of $1, right? And then we would pick, these are linear, so we only really need 2 points, right? So I pick another price like $2, and I repeat that process of adding up in the horizontal dimension. So now I could go up and say, okay, at a price of $2, firm one, let's say.
Hold on 1 moment. I have to.
Okay.
For a second.
Okay, are you with me?
Yes, I get it.
Okay, yeah. And then I would do the same thing at $2. And let's just say the units would be, 15 from firm one and 45 from firm two. And then at $2 for the industry, right, I would get 15 plus 25, I would get 40. Well, actually, it looks like it'd be more than that. But what's this look like? So maybe like 45 plus 15, we'll say like 60.
Okay.
And that would be another point here.
So horizontal sums can like, the horizontal line can move. It doesn't specifically like have to be just one.
No, and actually, so what we really want to do is do that for each and every possible price, right? So we just did it for two because these are linear marginal costs. So they're going to follow a straight line, and you only need 2 points to determine a straight line, so you're good. But in reality, what we would do is we would, for each and every price, we would add up the quantities that each of the individual firms supply. See how I'm moving it up and down?
Yes.
in order to get the corresponding quantity that would be produced at the industry level. So we add these up, the marginal costs are from 1 and the marginal costs are from 2, but we're adding them up in a horizontal direction. We're summing, in the direction of the arrow.
Okay, it makes sense.
Right. And the reason why economists go through the trouble of saying that and trying to be explicit about it is that these as mathematical functions, right? And I'm gonna go ahead and I'll write here, so MC1, remember, it's something like D1 times Q1. There's no intercept term. This is a linear function with a zero vertical intercept. And MC2 is some parameter, which is the coefficient, right? Some constant D2 times Q2. But if you have these two functions and you would normally add them, right, algebraically, then if you weren't careful, you would be stacking them in the vertical dimension. You see what I mean? So if I just, for example, and I'll just do a little bit of, I'll call it, they always tell you when you're teaching, they're like, never, ever, ever write anything on the board that is wrong. So I'm not going to do that right now, but I'm just going to tell you that if I just add these blindly together, the left and the right sides together, then I'll get MC1 plus MC2 is equal to D1 times Q1 plus D2 times Q2. And the resulting function will be like stacking MC1 on top of MC2. And I'll just move this over. It'd be like doing this, stacking them.
Okay. Yeah.
And we don't want to do that, because if we stack them, the meaning is lost. What we want to know is, okay, if these individual suppliers face a price of $1, how many units will they supply to the whole industry, right? And that's a horizontal stacking, not a vertical stacking.
Okay.
Right. So I'm trying to get it to illustrate the horizontal part. But yeah, so we have to be careful with the algebra. And this is one of the things that I go over in the lecture, but I'll just say it really quickly here and end with it. The joint MC, you have to algebra for horizontal sum. And so what you have to do is you have to do this process where step 1 is invert MC1 and MC2. Add the result. And 3 is invert again. And if you follow steps 1, 2, and 3, then you'll get a joint marginal cost function. And the joint marginal cost function algebraically will be MC joint is, and I'll put D times Q, where Q is the industry quantity. Q is equal to Q1 plus Q2 and D, and I'll just leave us there, right? Because we don't have enough time enough to finish all of the algebra right now thoroughly, and I don't want to skip past it.
Okay.
It is on the videos. It is on, you know, the cost curve videos, and there's a joint marginal cost function. But we'll come back here next time and finish it up really quickly. But the point is that we can get a joint marginal cost function for the two factories together, which is also our industry supply curve. So we'll talk about this more on Thursday. Does anybody have any questions for me? Okay. All right. So we'll pick this up next time, and, you know, move quickly to try to get you guys all ready for the third midterm. Okay. Watch the videos as much as you can, you know, judiciously, and I'll see you all on Thursday.
Thank you, Professor.
You're welcome. Take care. Bye.
Bye.